So recall the definition of a chord where endpoints are on the circle. Chords can be used in many ways. They can be related to radii, half of a chord, diameters, central angles, intercepted arcs, and right triangles. You're probably going to want to write this down, just to name a few. What's up? Okay, thank you. Okay, cool. Thank you. You'll have something where? What is it? Oh, you have to wait until after we're done with the lesson. All right, anybody still writing? Okay. All cut up? Okay. All right, so let's take a look at some of these rules. So we have theorem 10.3 and the converse. So theorem, if two chords in a circle or in congruent circles are congruent, then their central angles are congruent. The converse to this is that if two central angles in a circle or in congruent circles are congruent, then their chords are congruent. So in this case, what they're talking about with the chords is they're talking about MN and PQ. And what we're saying here is if angle NTM and PTQ are congruent, that means those chords are congruent, and vice versa. If these are congruent, then those angles are congruent. So if we take a look at this first example, it says in circle A, the measure of BAD equals the measure of EG, which is 90 degrees. And BC equals FE. So it says find the measure of EAG. So EAG is right here. And they're telling me that arc EG is 90 degrees. So if that's the case, this also has to be 90 degrees because it's a central angle. So that's just kind of a recap there. Now they want to know about arc BD. Well, here is B to D. And we said that that angle BAD, this right here, is also 90 degrees. So that makes arc BD also 90 degrees. And then they're saying which angle is congruent to BAC. So here's B to A to C. So they're talking about this little guy right there. Okay, they want to know which angle would be congruent. So in this case, it would be E to A to F. Okay, and that's because, remember, BC is equal to FE. Okay, so this is going to be equivalent to this. So that's why those two angles would be equivalent. Which segment is congruent to BD? So here's B to D, that's the chord, which means BD, oh goodness, there we go, is going to be congruent with chord EG. Questions on this? So we just took that theorem and we applied everything. Okay. Anything I can address? How are we doing? Okay. Anybody still writing? All right, let's take a look at the next theorem. So we have 10-4. So now we're talking about the arcs with the chords. So if two arcs in a circle or in congruent circles are congruent, then their chords are congruent. So they're talking about these arcs like MN and PQ. The converse to this is if two chords in a circle or in congruent circles are congruent, then their arcs are congruent. So vice versa works too. If the chords are congruent, then the arcs would be congruent. So if we take a look at, oops, I went a little too far up there. All right, so they want us to find x here. So what they're telling us is that right now this chord PQ and QR are congruent to each other, which means without a doubt, we know that our arc RS and PQ are also congruent to each other. So we would set this up as x plus 17 equals 4x minus 2. Subtract x from each side. That leaves me with 17 equals 4, oh, I'm sorry, not 4, oops, should be 3x minus 2. Then I'll add 2 to each side. Wait, was this? Oh, this was plus. My apologies. I'm going to have to subtract 2 from each side. I was wondering why that wasn't working out. Here we go. So this leaves me with 15 equals 3x. And we'll divide both sides by 3. So in this case, x is equal to 5. And if we substituted that in, we would see that PQ and RS are congruent. You okay? Oh, okay. Okay, I'll ask again. Are you okay? Okay. Sorry. I thought you looked confused at first and then like, oh, no, wait. All right, how we doing? Any questions? Anybody still writing? All right, let's take a look at theorem 10-5. So if chords are equidistant from the center of a circle or centers of congruent circles, then they are congruent. So they're talking about these two being equidistant or being congruent. That would make these two congruent to each other. If the chords in a circle or in congruent circles are congruent, so they're saying if DC and AB are congruent, then they are equidistant from the center. So that means these two distances would be congruent as well. Also notice here that these, do you guys remember when we talked about the tangent lines and how we had that they were perpendicular, right, to form those right triangles? This also is perpendicular to those chords, okay? So please keep that in mind as we work on this. Now let's take a look at our example. So we have find KL and find NM. So here's what we have. We know that these are equidistant, which means JM and KL should be congruent to one another. So if we're going to find KL, we can see here K to L, if these two are congruent, KL is going to be 15 plus 15, which gives us a total of 30. So we know KL is equal to 30. Because this is 15, we have another tick mark here, which means this is acting as kind of like a bisector. Now for NM, they want us to find this line, which actually acts as a radius. Now we know these are equidistant. So that means if this is 30, we also know that this and this would be congruent. So we have enough information here in order to find what this radius is without necessarily working on anything. So we can state that NL is congruent to NM, and that's because all radii are congruent. So without applying the Pythagorean theorem, we know that NM, oh, wait a minute. No, I'm sorry. That was part of that, wasn't it? My apologies. But we have enough information to apply the Pythagorean theorem here. So this would be 8 squared plus 15 squared equals, in this case, let's say NL squared. So this will be 64 plus 225. So NL squared is going to equal, I've got 289. And then I take the square root of each side. So this will be NL is equal to 17. And since they're both equivalent to each other, we know that NM is also 17. Yeah, sorry, I was getting confused. I thought that was the 15 was that. So questions on that one? Sorry, I forgot that was the leg. Try the back three on your own. We'll go over them in a few minutes. Okay? I'll set a timer. I think 5 minutes should do it. Show of hands. Who's still working on these three? No? All right, big reveal. Here we go. So here's the first one. So if CAB equals 50 degrees, what other conclusions can you make about circle A? Explain. Well, DAE would have to be 50 degrees. That's not true, guys. These are not vertical angles, so don't add this part. That's not true. But DAE would be 50 degrees because you have CAB, C to A to B would be 50, but this would be 50, but that's because of the arcs and the chords are congruent, so the arcs, these are not vertical angles. So do not add that part, okay? But CB and DC would be congruent because since these two chords are congruent, the central angles end up being congruent, but that also means the arcs are also congruent, okay? Sorry about the vertical angles. I don't know why that's in there. Someone made a mistake. Any questions? All right, second one, given AB is equal to CD. So here's AB, this is equal to CD. What is the length of AB? Well, if that's 35, you're multiplying it by 2, it's just 70 because they have the congruency marks given to you. Okay? Any questions on that? Would also make CD 70 as well. And since these would be congruent, these would be equidistant. So if this is 12, this would have to be 12 as well. Okay? And the last one, given AB is equal to DC, what is the radius of circle O? So what we're doing here is we have this side is 35. This is 12 that they give us because it was equidistant. That's what we just talked about. So if this is 35, that's 12. We apply the Pythagorean theorem to find this radii, which ends up being 37 in the end. Again, that's applying Pythagorean theorem. Are there any questions? Oh, that was the 5 minutes. Anything at all? Homework's on Delta Math, but just like yesterday, be careful. Okay, you're only allowed 4 attempts. No resets will be given. So take your time on the problems because they're all custom this time. Okay? Huh? Yeah, let me write you a pass. Where you heading? Huh? Miss who? Hornet? Hornet? I have a, I'm partly deaf.
Miss
So
Horny.
Hornet.
Yeah.
Oh, I have no clue that. Yeah, sorry, I have no clue who that is, but I will write you that. Hornet, right? No. About what wing is it? 400. Okay. There you go. Okay. Those who are watching at home, have a great day.